So today we'll start with the agenda. We are taking a look at this resource, and this resource has been framed through what we call the levels of knowing. It is by a professor named Sharma, Maharesh Sharma. And so we're going to start by talking about who is he, what is this progression that he has set up for us, and then we're going to take a look at the resource and how it is there for a support to us teaching math concepts. And we're going to look at it through a linear function math standard. And then we'll show you where it's going to be located and then save some time for some questions. So who is Sharma and what are his levels of knowing? Professor Sharma is just, he's a specialist in math, and he has worked primarily with students who are struggling in math. So he has some good dyslexia support tips and things. But as he was working with students who were struggling in math, he kind of identified these levels of what he calls levels of knowing. And it's his way of saying that a student needs to begin here and finish here in order to really have full understanding of the math concept being presented. The levels are of knowing go in this order. So the first one he calls intuitive. And the intuitive stage is where students are entering, it's kind of like a low floor, high ceiling level where students are entering with something that's intrinsically doable, solvable. They have been it's either building on prior knowledge or it is creating a problem that they are able to kind of dive in and solve by drawing pictures or using manipulatives or whatever aspects they have on hand, but it is something that's at a level that they can just walk into. So it's intuitive. They can trust their gut, they have some understanding, and they can begin solving. The next level is what we call concrete. And concrete is where students are able to think about that problem using manipulatives. Students should really be physically rearranging things, whether it be pieces of paper, whether it be wood blocks, fake money. They should be physically kind of playing with the math. So this traditionally has been really looked at as lower elementary type of activities, but it is part of really being able to kind of grab hold of the math concept together. The third level is called pictorial. And when students move into the pictorial level, students are taking the blocks and things like algebra tiles, as Chris stated. They're taking those and they're able to now represent them in pictorial form, or they could represent them in a table or a coordinate grid. We are starting to move from physically manipulating tools into just showing that two-dimensional look on a piece of paper. The fourth level is called abstract. And in the abstract level, this is where students begin to write equations or number sentences for the work that they've been working on in the concrete or intuitive, concrete, and pictorial levels. Most of our textbooks start here, which is why it's highlighted blue there. Most things that our students are presented with are given to them as an equation already, and students are being asked to go back and connect to the concept and then move ahead into the next phases. The fifth level here is called application, and that is where students will begin to take those equations that they created in the abstract level and apply them to context scenarios presented in real life types of situations. Sometimes our word problems represent this, but they should be something that's contextual to to life, to living, and where we would use that equation. And then the last and final level is called communication. And this is where we're hoping students can arrive. We want to get them to this point. And this is where students are able to articulate and explain their reasoning, how they set up an equation, what the parts of the equation are, where they're represented in the life scenario. This is actually like what we are as teachers, right? We are able to articulate or explain back to someone our learning. So we're hoping that students get to this level. So today we're going to work through these 6 levels of knowing, but we're going to do that with one math skill. What we have found is that in ABE, we have such a wide variety of backgrounds that come into teaching, and we kind of are asked to teach it all. So many of us are not trained math teachers, so we don't know when we come to a math skill, we don't know where it begins and where it is going. We just know what the book is asking us to accomplish. Kind of like Pam said today, it's about finding the answer. And so what we want to do is we want to pull back a little bit and see where would the student have needed to come from to get to this abstract level, and where does the student need to go forward from the abstract level. We also have teachers who maybe were trained in elementary education and they can do intuitive, concrete, and pictorial and touch into the abstract, but we don't need to go forward into the real life. The kids weren't old enough. We weren't trained to necessarily teach them about budgeting or about solving percentages while we're shopping, because that wasn't applicable to that age group. Likewise, we have high school math teachers who they are getting students who come in. We've been trained that these students have come in and they have already completed the intuitive, concrete, and pictorial in the elementary years. And so we're starting right with formulas and equations up there in the abstract and the application and moving them through those last few levels. So our students are kind of all over the place, and so are the teachers. And we're kind of trying to, at Atlas, provide a resource that helps us take a look at math skill and see where should it begin through the levels of knowing and where should we work through towards the end. We as teachers are going to have to do a little bit of formative assessing and know where our students are actually at in this progression. Not all students will be in the abstract. Not all students will be in the concrete. Not all students will be up in the communication. So to kind of know where our students are at in the progression will also be helpful for us as teachers. This resource is provided for you to kind of see the overall progression and know where should I build and where should I move our students to. So today we're going to take a look at this standard. That's a pretty common one for the GED level. It's a level D standard, and it is to construct a function to model a linear relationship between two quantities, determine the rate of change and initial value of the function from a description of a relationship or from two XY values, including reading these from a table or from a graph. Interpret the rate of change and initial value of a linear function in terms of the situation it models and in terms of its graph or table of values. That is a lot to accomplish in one standard with our students. So what would it look like to get them there? We'll start with the objective. The teacher objective is that students are going to be able to write an algebraic equation for a linear relationship based on a given scenario, illustrating understanding of the relationship of the dependent and the independent values and how slope and the y-intercept affect that linear function. For students, we might say something like, I can write a number sentence or algebraic equation that represents a relationship in a given situation. And that might seem a little bit oversimplified, but in student terms, they're not going to have all of our lingo to be able to articulate what they need to be doing. Any questions so far about what we're going to be doing or about the levels of knowing? All right, so we're going to be thinking about linear functions, and we're going to start at the beginning of Sharma's levels. And he says this is the intuitive level. And in the intuitive level, remember we talked about this is a building on prior knowledge. So an example of this I might propose is you are planning a party for your child's graduation at the local community center. You have two folding chairs of your own, and you have asked friends and family to use any folding tables and chairs that they may have. You are trying to rearrange the tables and chairs to fit the long rectangular room. To do this, you must push the tables together to form one long table. How will you determine the number of people you can comfortably sit if your friends and family have brought 5 square standard folding tables? So I'm just going to give you a minute to kind of think about the problem. Think about how you would make sense of it. And then how your students would make sense of it. Where do you think they would begin? Or what could they do to begin to process this information? They could draw it. They would probably, if they could grab some tables in the classroom. I think my students would start drawing. And I teach at a like GED level. Student would draw. Yeah, that's a good one, Jane. It's coming. They might ask though, and that's hopefully they know to ask that. Do we have anything that we could use? But they are starting to formulate ideas. They've moved tables and chairs around before. They've had parties before. Start thinking about the format. Yes. And I kind of had to like kind of mold that it's one long rectangular room, putting it together. But they might ask those questions. Do we have to? Yeah, one person on each side of the table. They're starting to process. This is like low floor, high ceiling. They can come in and they can start having a conversation and thinking about making sense of how to tackle this problem. They're not without skills to do this. The next level we're going to be moving them to is exactly what Jane was mentioning. Is at this point, we want students to be able to manipulate something physically. Chris said the tables in the room. Jane says 1 inch tile blocks. But it's definitely something physical for those kinesthetic learners to begin to rearrange and think about how many chairs they're going to be able to fit. Yeah, if you had enough doll furniture, you could probably do that. Um, again, most of our textbooks start way beyond this, and a lot of us are not comfortable with manipulatives. We haven't used manipulatives for a long time. What could we use to build that concrete physical interaction with the problem? We could use coins. Yeah, nobody said it had to be a square table, could be a circle table. You can have pieces of paper cut out. Some of us have the inch tile blocks. If you don't have them, or you're teaching online or in DOC, there is an online free manipulative website here called Number Frames, and I do have the link in the slides so you can access that. But students would be able then to begin to physically operate or work out the problem. Thank you, Amber, for putting that in the chat box. So they might decide now to start, they could use circles or squares, whichever they prefer. I'm using circles for my chairs and squares for my table. And they could begin to sort out this pattern so that we were looking for 5 tables. So we would start with, oh, we don't have any 0 tables. And maybe your students would do this and maybe they wouldn't start with 0. And that's okay if they don't. It's a good conversation later. The idea is that they're being able to manipulate this in and create the problem themselves to be able to work through how many chairs they would be able to place around these tables in order to sit people. So we have 2 tables, we have 3 tables. We're going to come down and grab the 2 chairs we started with. And then how many more chairs are we needing? So we'll come in there and we'll add our extra table, our extra chairs needed. So students are physically completing the pattern. Of the equation without even realizing that they're working through a function. And then we move to 4. And you can tell me in the chat box if you know how many people will comfortably sit around 5 tables. Maybe you've already figured it out. Yes, Desmos has Polypad is another one. I haven't played with it enough, but I know we do this one for my paraeducator class. We use this one because they're always working with base 10 and things that 12. Is that a question mark? I'm not sure. Or I'm waiting to see if other people put their guess in the chat box. So we're adding chairs, and each time they're adding chairs, we're thinking about what is staying the same and what is changing. And that is something that you can build into your lesson as you're working through it with your students, but you're allowing them to kind of explore themselves. Yep, don't forget your chairs. So now we're on 4 tables and we have 8 blue and 2 of the ones that I had to start with. Oops. And then I'll do 5 tables. And as they're creating it, maybe they're seeing it, maybe they're not seeing it. That there should be a building. Some of them will get really fast and they'll just stop adding their pieces because they already know what's happening. My 2 chairs that I started with, and then the chairs that I need from family and friends. Okay. But one person is sitting kind of far away. Come back over. There we go. So once we have 5 tables, we can see that we need a total of 12 chairs. And students have done that physically. This is the concrete level. They're actually rearranging things, manipulatives to represent our chairs and tables. All right, and then let me, Zoom is not my normal platform. I'll jump back over here to show you. So in our resource, working through the progression, you will see the picture of the manipulatives and links to represent how students are concretely working through this function. 2 chairs I start with, I don't have any tables. What happens when I have 1 table and my 2 chairs? I need 2 more chairs from friends and family. So with every table, I'm adding 2 blue chairs. I need 2 chairs from friends and family. In the third level of Sharma, he says, now we're going to take those little manipulatives and we're going to transfer them to a pictorial representation. And when we start out in my classroom, when we start out with this, we start out with actually the physical representation of the manipulative we were working with. So you can see here, we kind of drew the circles and the squares for the chairs and the tables until we worked through the 5 that we needed. Eventually, though, we're going to start moving our students into what it would look like to put it into a table or even a graph, a coordinate graph. The pictorial level, in my experience, this one and the abstract takes your longest amount of prep. It takes students the most amount of time to grasp the concept because you want to spend some time here really developing that. We have students who start at the abstract and they know how to write formulas and process equations, but they don't really know how these things are represented in situations or scenarios. And so we're giving them the opportunity to kind of go back into where it began and connect the dots. So here we would encourage students to label where is the chairs, what number is represented by the chairs, what number is represented by the tables. And then as we move into setting up our table, you're going to have that discussion. Well, which heading label, which column would be represent the tables and which one would represent the chairs? I have intentionally color coded this. If this was the first time I'm doing this activity with my students, I would color code and really let them see what stays the same and what changes. They're not going to color code. They're going to call all chairs are going to be the same color, and that's okay. This is a discussion we can come back to and ask them when we start beginning to set up those tables. We started with 0 tables. How many chairs did we have? What does that look like? Because we'll find most students probably won't start at the 0. They'll start with 1 table. And it's a good discussion. Yeah. We really have to go slow to go faster. So this level I have found is the biggest level of kind of connecting the dots, really creating that bridge. Some examples I've done with my students. So we started with the scenario. In this resource, it will only take a look at the levels and it'll be a snapshot of what it looks like to be in the intuitive level. What does it look like to be in the concrete? What does it look like to be in the pictorial, and so on. For today's purposes, I will also show some student work. So you're not going to start teaching a concept and only do one activity in the pictorial and concrete levels. You probably will do several. And so once they get the hang of setting up their pictorial representation, and they can move into charts or graphs, then you can actually move to the next level. But this takes some time to kind of build up. And so one thing that I recommend is if you're working with functions, to go to Von Wynn's visual number patterns. Yeah, it takes time for them to see it and to continue to build it. So we started with that situation. We got the concept that we're rearranging tables and chairs. We're seeing numbers that come in and numbers that come out. We're thinking about what was the dependent and what was the independent variables. How do we know that? What was the question asking for? How did we know that the chairs were dependent upon the tables? All of this happens here as we're setting up all that pictorial representation. So with most of my students, I will start with that scenario, then I'm going to move into practicing more. It's procedural skill and fluency. We go to the visual number patterns website, and I pick out a few. I do have to try them out myself. So that's your fair warning there. Don't just grab one and hope that it's a linear function. It might not be. So make sure that you can make sense of it and set it up, and then that will be more helpful for your lesson. But the next step would be that they would try some. And this takes students a little bit, even mine who are really great with functions, to think about it visually takes some practice. The questions I'm always asking is what's staying the same and what's changing. So we'll start with like a notice and wonder. You can see my students there are commenting on this this sequence of blocks. I'll give you a minute to read some of what they said. Thank you, Amber, for putting that in the chat. I don't know if you can see that one or if it's a little bit small. But first, we just want to build their curiosity again, kind of coming back to that intuitive. Even though we're at the pictorial level, we're still kind of seeing what we notice and what we wonder. So within this pictorial, we're really developing that what's staying the same and what's changing. Once we get to the abstract level, you're going to see these two levels kind of merge for a little bit. We can't just jump right into equations. We're going to move our pictorial thinking into what does it look like to write it as an algebraic equation or a number sentence. And students might start by thinking of it in a word sentence. You know, the total number of chairs is equal to 2 times the number of tables plus the 2 chairs I started with. So really getting them to notice and wonder, and then also to what stays the same and what changes. Maybe you can see it there if I enlarge. So the first time you're going through it, you might color code this just to help the students kind of grab hold of that. And you might not. It might be a class discussion. They might have to find it. That's okay too. We don't want to overfeed them knowledge, but giving them opportunities is to grasp it is also okay. You know your students best. Now from here, we're going to move into setting up the equation. What does it look like to have the total number of chairs is what we're searching for as our dependent. And what is it dependent on? Well, it's dependent on the number of tables we have and the 2 chairs we started with. So students will start writing these number sentences. You are given the opportunity here to kind of build in slope-intercept form or function notation, whichever one you're working with. But students can see the visual representation of what's happening in that rate and with the intercept. Feel free to ask me any questions if you like. Thank you, Mark. Yeah, I do word sentences for every single math problem I do first because the number one problem for our students, right, is that they don't understand the question, even if they're English speakers. And they just jump and they just assume. And so pulling back and making them make sense of it in word form is super helpful, especially when you get to algebraic problems where they really have to like, wait, what's going on? Because those questions are like a paragraph long. All right, some student work again. We tried this with another pattern, kind of, we were talking about tables and chairs another time also. And this is another one from that visual number patterns. We started with what you notice and what you wonder. Do you see a pattern? Describe what you notice. And then I moved them to, could you set it up in a table? What would be your X and what would be your Y? And then I asked them, what do you think the rule would be? And could you write that in our function notation? So now I'm really blending. I'm pushing them from the pictorial into moving into that algebraic equation. This is the abstract level. And I don't think they actually have the function notation right here. I think this is actually not correct. I can't remember because I'm not solving it at the moment. But you can see that there's going to be discussion and thought behind whether making sense of it along the way. Here's another example from the visual number patterns I did with the stars. Again, I'm asking them, now I'm kind of pushing them further. I'm saying how many would be in the 17th step? And is there a rule? Could you explain it in words? Could you write it? And then another team. And they actually came up with the function and they could substitute it in. This takes time. These two lessons take time. For most of my experience, what I've noticed is that our students fell off the edge of math somewhere in the junior high, middle school level, where they were learning these concepts, and then all of a sudden they switched to algebra and geometry and they lost it. They couldn't keep that, the bridge wasn't there to connect them to those concepts and to the equations. So these two levels I have found for most of our students to be the most imperative, like to really spend time in this level, in these two levels. Our fifth level here, application, we're trying to get them to accomplish that linear function, writing an equation that's based on a scenario, knowing what's our dependent versus what's our independent. So now we're gonna be looking at a textbook example of a situation, and this one is Matt pays a fee to join a gym, and then he pays equal monthly dues to use the gym. The graph shows the relationship between the number of months that Matt has been a member of the gym and the total amount he has paid. Write an equation that models the line in the graph below to find the total amount Matt pays for the gym membership. This is straight from the TABE 11 and 12 math book. And I do have it referenced here if you'd like to see the whole page. But I'm just going to pull out just this one problem. It's a common one we would take a look at. They provided us with a pictorial or with a picture, an image to the problem. And our students need to be able to write the equation. And we hear this all the time. Can you find the equation of the line? Can they write that? This is a gym membership. It's a real life application. They're applying this to a linear function. The next steps, part of the questions are not only can they write the equation, but can they explain what is he paying to join the gym? What is he paying for his membership? Not only just total, but the rate. So being able to identify now, did Matt start at 0? Does like Matt have to only pay $28 a month? What is the $28 a month? What is the $40? How are those represented in our equation and on our graph? And this allows us to kind of challenge the students on what would be a good representation of the range and I'm having a brain fart. What's it called? Range and see X values. What would be a good domain? Thank you, Mark. Domain and range. So could we have negative numbers? Would that be viable for the money he's paying or the months he's attending? And could the money he be paying be less than $40 for the first month? Yeah. And how do we know if the gym starts paying me? That would be great. And that's a good illustration to our students because they'll say, oh, well, it works on the graph. So this is the application level. Now they're being able to take the equations that they've written and identified the parts of the slope and the rate, the y-intercept and the total, knowing what is the independent versus dependent. And all those parts are coming together now in a real life application. And then our last level here is communication. And this is where the students are going to be able to explain, interpret the concept, demonstrate or show that they understand Matt paid $40. That's a fee. That's only a one time. We can't multiply that times every month. We're only going to add it one time. Can they explain the relationships? And it's giving them opportunity to do this. Hopefully we've done a little bit along the way for this, but this might be considered a formative or summative assessment you might want to give. Again, I included an example from a pre-algebra workbook where they are renting a canoe, real life problem, no pictures to assist here, no graphs, no tables. And they need to be able to answer all of those questions based on the parts and of the equation that they themselves have to create based on the scenario. I would do this with partners. They could do it individually and do a class share, but that they are able to apply all pieces of the linear function and explain it to someone else is our last level with Sharma. Again, that reference is listed there from the McDougall Little pre-algebra book. So this resource is up and coming. It will be listed on the Atlas's website under levels of knowing mathematics. It is starting to be filled. This is the first lesson that's coming. And again, it's a progression lesson. It is not a lesson on how to teach linear functions specifically, but what does each level look like in a student's learning if they are learning linear functions according to our standard 8.f.4. What would it look like for those students along the way? And us as teachers are going to be able to identify where our students are at and maybe what we need to kind of build back up if they are missing that, or where we need to push them forward in this progression. Questions on this? Understanding Sharma's levels through a math skill or a math standard. All right. Yeah, so just there as your reference. And I think Amber put it in the chat box there for you on the Atlas website. If you don't have any questions for me, you're welcome. You're welcome. It's a Friday afternoon and you've been thinking hard today. Have a good weekend.